All right, good morning, everyone. We are going to continue practicing our FRQ. So this is number 4 from a previous AP exam, the same one that we've been working with all week. So let's get started. A researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 12 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not reasonable. Okay, so looking at this, we can say that we are definitely going to look at a type of mean test because we have mean listed here. So they want us to construct a confidence interval for the mean difference. So there are 2 different types of tests that calculate difference. That is a 2-sample t-test and a paired t-test. So I need to note the difference between the 2. I know that a paired t-test, the samples come from the same population, whereas a 2-sample t-test, we have 1 sample taken from one population and another sample taken from another population, different population. So because we are taking the samples from the same population, this will be a paired t-test. So we need to use the paired t confidence interval formula. So let's go ahead and write that down. So for part A here, we have our general formula is our statistic plus or minus our critical value times the standard deviation of the statistic. So in this case, our statistic is going to be the difference between the means, so x bar sub d, plus or minus. Our critical value is going to be a t because this is a paired t-test. And then our standard deviation of the statistic is going to be the standard deviation of the difference over the square root of n. Okay, so before I even proceed with these calculations, I need to check my conditions because they don't say the conditions have been met. And so for each a significance test and a confidence interval, I need to check my conditions. So looking at this, we need to do our RINs here, or the NER, whichever you prefer. So random here, they already say that we've concluded that this is random because they say they choose the seeds randomly. The independence here, it says looking at, we come from a large number of Roma tomato seeds, so we have a large population. So independence, since we have a large population, I'm gonna finish this first thought. So randomly chosen seeds, independent since large population. And the normal condition here, there are 24 seeds randomly chosen, and they randomly assign the containers. So we're good with the random. We're good with the independence. However, the normal here, it says they indicate that the assumption of normality is not reasonable. So we can say that normality is not reasonable. And because we are using a t-test, the normal condition isn't so important here. So we can say that, or we can continue with the problem just because a t-test does not necessarily require us to be normal. If this were a z-test, then yes, we would have to absolutely meet this condition to proceed. But because it's a t-test, it's okay. So now we can continue So the mean here, the difference, is going to be indicated in the table. So negative 2.015 plus or minus our t. Okay, so our t, we know we need two things to get our critical value. The first one, we need our degrees of freedom, which is n minus 1. So in this case, we have 12 minus 1. And then we need our confidence level. Well, here they don't give us a confidence level, so we can assume that it is 95%. So if I go to my t-table here, I'm looking in row 11, since we have 11 degrees of freedom, and I look at 95% confidence. So that gives me the t of 2.201. And then my standard deviation of the difference, well, they've already calculated that for us, so 1.163 divided by the square root of n, which in this case is 12. And if we go ahead and we compute this, we should get negative 2.75 to negative 1.28. But we're not done with this problem just yet, because they say be sure to interpret the interval. So the interpretation here is part of your solution. If you do not include it, it is not correct. So they're saying we're trying to see the difference between the untreated and the treated seeds. So we can say we are 95% confident that the mean difference in growth is between negative 2.75, what is this measured in? Centimeters, I believe. Let's double check. What is our unit here? Oh, yep, centimeters, okay. So the difference in growth is between negative 2.75 centimeters and negative 1.28 centimeters. All right, so now we're done with part A, so now we can do part B. So it says, based on the confidence interval in part A, is there sufficient evidence to conclude that there is a significant mean difference in the growth of plants from untreated seeds and the plants from treated seeds? So here, they're asking you, is there a significance difference? But it's asking you to use the confidence interval to justify. So it's not necessarily saying, we want you to conduct a significance test. They want you to use the work that you've already done to make a conclusion. So our first step for anything regarding a significance, whether you're actually doing the calculations or not, we need to state our hypotheses. So because this is a paired t-test, we are always going to use the same hypotheses. So our null is going to be that the mean difference is equal to 0, and our alternate is that the mean difference is not equal to 0. And we can say, so let's rewrite our interval that we had on the previous page. So negative 2.75 and negative 1.28. So the point of a confidence interval is to estimate the population values. So we're trying to say that our null hypothesis is 0. And then the alternate hypothesis is that it's not equal to 0. So looking at this problem here, is that are either of these hypotheses located in this interval? Because the interval is trying to approximate the population value. And so looking at this, is 0 included in this interval? Is our population value of mu being equal to 0 included in the interval? Well, it's not. So that gives us enough evidence to say that the mean difference is not equal to 0, since that value is 0 is not located in this confidence interval. So our conclusion would be, since the 95% confidence interval does not include 0, the null hypothesis can be rejected at the alpha equals 0.05 level. So, therefore, there is statistical evidence at the alpha equals 0.05 level to say there is a mean difference between the growth of untreated seeds and treated seeds. And then we're done with part B. So part B really did not ask you to write or to really calculate anything. Part B is purely logic based, and because we know that a confidence interval is trying to estimate the population value, since the population value of mu equaling 0 was not located in that confidence interval, there is sufficient evidence to say that the mean difference is not equal to 0. So this interpretation here is the key to this problem. So again, there's no calculation involved because they ask you to use the confidence interval that you've already calculated. And then the other piece here, make sure that you include your hypotheses, just because you are going to refer to your hypotheses in your conclusion, and if you don't have them, then I don't know what null hypothesis you're rejecting, so we need to make sure that we include those. All right, so now you can get started on your classwork, and please make sure you're joining the Zoom call by 8:20, otherwise you will be locked out of the call and marked or you will not receive the credit for attending the Zoom call for the day. So please make sure that you are logged on, and we will do some of the classwork together, and I'll be there to answer any questions that you may have. All right, have a great rest of your day, everyone.